mean, I'm not gonna, go into details now on the approach of semantic interoperability because this is just the demo part, right? So, and for the demo part, I'm gonna show you this how it works, all these components through one of our pilots in AD4GD. In particular, is the pilot of water level in Berlin for the lakes in Berlin. This comes from the general architecture from AD4GD, and I think that Joan has already talked a little bit on how all of the different components are part of this architecture. So I'm just going to give you like a flow, and then I will show you live how it works. Right? So we start from the data sources. In this case, data is collected in CSV files. Then they are put together and gathered into our main storage in AD4GD, which is basically a MinIO. We have an MQTT broker, which basically is providing the listening and firing mechanisms to do something when a new resource is added to this storage, right? So every time a new data set comes to MinIO, this is published, of course, into the channel in the MQTT broker, and then the subscribed component, in this case, is basically a Python script, is launching the data harmonization automatically. So this is basically what you see in number 4, the data preparation and semantic uplift pipelines. These are launched automatically. This executes, of course, all the process of data harmonization, putting this in alignment with the Green Deal information model. Basically, because these are sensor data, at the end becomes data that is represented according to SOSA, SSN, and using the properties, standard properties that we define in our vocabularies in AD4GD. And then this data goes back to another place in the MinIO. From that, then comes another automatic workflow that is launching the machine learning. So it's taking all of the harmonized data, doing all the predictions, calculations, and of course, providing some results that are going again back to the MinIO. So from there, we have many different interfaces, as you can see. One is, of course, the actual user interface, and that was shown actually during the break. Then we also store the harmonized data not only in the MinIO but also in a database, in a semantic database. And because it's harmonized, we can use another service of AD4GD, which is called the STA generation service, which automatically generates a SensorThings API from this dataset. So the user doesn't need, of course, to do nothing else, rather just to start from the CSV, and he gets all the data directly accessible via this standard API. And then the last step is here, where we actually can also publish this SensorThings API into the Green Deal data space through an Eclipse connector. So we put it, this endpoint into the EDC, and then the users, consumers can get the data from this endpoint and navigate, of course, all the different endpoints of the SensorThings API. So that's the flow. And let me, sorry. One of my windows where I have. Yeah, okay. So this is our MinIO. So you see this is our storage. One of the buckets is called Pilot 1. Inside Pilot 1, we have daily data, the water level, and we have different data sets, as also you can imagine, right? So we have water level, we have water temperature, we have meteorological data, and they are coming from different sources, and they are represented according to different models. And the harmonization is actually putting them in a harmonized way, in standardized form. So these are coming, automatically also, because one of our partners is collecting them, these CSV files, every week, and they're putting them into this MinIO. So, just as an example, I download one of those CSV files, and I'm just calling it like testing GDDS CSV file, which you can see. This is like the readings of 1 week for this lake. This is just a CSV file in a very semi-structured way with the reading of the water level in one lake. So I put this CSV file into the MinIO. And that is open.
Is this the Berlin Lake stuff?
Yes, this is the Berlin Lake stuff.
The brilliant Berlin lake. We have the expert in lakes here, by the way.
Yes.
The local guy.
Local.
Berlinese.
We have our use case partner is here, of course, giving us all the information about Berlin lakes. So I put this here, okay, and of course, well, this is, as you will see, so now I just uploaded today at 10:41. So these, of course, launching the servers, all the process of harmonization, and then I will just, there is another bucket in the MinIO, which is called the harmonized. And so the idea is once the data is, finalize the harmonization, another file will become available here. Yes?
Is it harmonized to go from the unique format of, I think it's KLW, but I may have that wrong, the Berlin source?
Yeah.
To a standard source, and
Yes.
how do you know what it is, but how do you know? Because it's in your head or because it's coded somewhere?
Yeah, I will show you. So I will show you the pipeline, how it's done in the back. But yeah, so of course, one of the important things is that we need at the end some kind of, you see the new file added now. So basically I will just download it. So this is a JSON LD file. So here, and this is just the collection of observation for this lake for this particular week. So you see, of course, the feature of interest is this lake. And you have also, of course, information about this lake, the geometry, blah, blah, blah. And then you have each of the observations for each of the days with the units that are standardized, and of course the timing and so on. And also you have, well, the sensor, the properties, and all of these connections that are being standardized. So this is just one very simple file, right? That is just about 1 week of one lake. Okay, so how is exactly the pipeline done? That's the question. So basically, we have, of course, our toolkit, which we call this data preparation and integration pipeline. The toolkit is available in different ways. It's a command line tool, it's available as a web service, and of course, we have like a user interface, which is this one, right? Which allows you also to use this pipeline. So I will log in here.
Can I ask about the actual installation of the sensors? Any minimum number of sensors per lake, or like an interval, like between 2 stations? How does it work?
There are, I think, 18 lakes in Berlin that are more, I would call them medium sized, so they're a little larger, and most of them are allowed to swim in. And in those lakes, there are water level sensors and water temperature sensors installed. So it does not matter on the distance between the lakes. It's,
but it could be one sensor per lake, or I don't know, any minimum numbers that you need.
It's only one sensor per lake.
One sensor per lake.
Yeah.
So, okay, so as you see, when I go to the this tool and I go to the user interface, I can see the pipeline that I have defined. So the last one is, this one is the water level final. And it's very simple thing. I'm just telling where is the input data, what type of source here is, and the most important, or the magic that you call it, is the mapping, of course. This is like where we need to specify how to go from the source to the target. Our target, of course, is the Green Deal information model. Then we tell him how to transform the data, post-process the data, and we also store this data in the database as I mentioned before. So it goes to a triple store and store it into this graph. So I will show you just the mapping also, so you have an idea. You don't need to really get too technical on this, but so that you see at least that is something real, concrete. So this is the mapping. There are many ways of specifying mappings. We provide a mapping in YAML. This is like a very simple way of specifying a mapping that we are saying, okay, so this is, how my main type of entity is going to be an observation collection, what kind of level I want to provide to this observation collection, everything that is within this, brackets or
Inverted commas.
Curly brackets.
Curly brackets.
this is coming from the source, right? So these are like the fields on the source. And of course, I'm telling you the feature of interest, the observed property, the members, and blah, blah, blah. So this is like a very simple mapping. And actually now, just to tell you what we want to continue doing in projects like Sage, is that this mapping will be generated automatically semi-automatically with the help of AI. So this is, we are providing a service that is helping in the generation of that. So that's how the pipeline is specified. And of course, like I said, you can execute the pipeline directly from here, or you can call the API. So this is the API of the pipelines. So basically, there is an execute here, and I just tell the idea of the pipeline that I want to execute, and that's it, right? That's what it's happening. Now, the next thing is I want to provide access. Sorry. The next thing is I want to provide access to the results data through a standard API, OGC SensorThings API. So we have this other service that we tell him, take the data that is in this graph that I just showed you where it's stored in the database, and create me an endpoint, and SensorThings endpoints to access this data in a standardized form. So this is like the definition here. You see, it's very simple. I'm just telling where is the graph and where he will get the data, and he gives me back an endpoint of the SensorThings API.
Mm-hmm.
And this endpoint is basically giving me the data via SensorThings API, and I can navigate this data using SensorThings API.
Mm-hmm.
And so on. So, moving fast, the last thing is about the connector. Okay, the connector I will show you as in the next demo.
Yeah.
But so this is the part that just shows you until the data is harmonized and how you can access the data via standard APIs. Basically.